Hello friends, my name is Ikshans and welcome to CADDD Academy. In this lecture we will cover the MILLMAN'S theorem. The statement for the MILLMAN'S theorem is, as written here, any number of current sources or the voltage sources in parallel can be replaced by a single voltage source whose current is the algebraic sum of individual source currents, and source resistance is the parallel combination of individual source resistances. This statement looks quite difficult to understand. Now we will see the simple explanation of MILLMAN'S theorem, and we will do an example problem to understand the MILLMAN'S theorem very easily. So what this statement is saying here, that if we have like voltage sources, like this one is V1, and we have a resistance R1, and which is connected in series with the voltage source, and after that we have voltage sources, again V2 and this R2. Okay, after that we have V3, and here we have R3, and so on. Okay, and this goes up to Vn, and the resistance here is what? Rn. So if we have a circuit like this, then we can reduce this circuit into a circuit which has a voltage Vn, resistance Rm. Vm means MILLMAN'S voltage and Rm means MILLMAN'S resistance. So this whole circuit is converted into this circuit, and these two terminals, let's say this is A terminal and this one is P terminal. So this will be A terminal, this will be B terminal. Okay, now what is the value of Vm and the Rm? Okay, now we will see that Vm is equal to summation of from 1 to n Vi by Ri. This equation again is going to be little bit complex, but we will understand this equation using the example. So this is the value of Vm, and the value of Rm is what? Reciprocal of sum of all the resistances reciprocal. So these two are the formulas for Vm and Rm. Now we will do an example problem and will understand the MILLMAN'S theorem in very simplified manner. Okay, so the problem I'm taking here is taking a simple problem, like we have resistance of 1 ohm and the voltage source of 10 volt here. Okay, after that we have resistance of 2 ohms and voltage source of 20 volts. Okay, after that we have 3 ohms resistance and 30 volts voltage source. Okay, and we have another branch which has only 5 ohm resistance, like this. Okay, and we have to calculate this I current which is flowing through the 5 ohm branch. Okay, now this section this section of the circuit, it can be converted as this circuit. Let's assume that this point is A, this point is B. Okay, now we have this type of circuit here, and this type of circuit can be converted as this type of circuit very easily by using the MILLMAN'S theorem. Now what we have to do for this is we have to calculate the Vm value. How we will calculate the Vm value? It is very easy. Now what we have to do, we have to write voltage above, okay, 10 volt divided by that resistance plus 20 volt, this one, divided by this resistance plus 30 volt divided by this resistance, and divide the whole thing by 1 by this resistance. Just take the reciprocal of all the resistance and add all those resistances. Okay, so 1 by 1, 1 by 2, 1 by 3, and this is what the value of Vm, and this will be 10 plus 10 plus 10 divided by 6 plus 3 plus 2 divided by 6. So this whole thing will be 30 into 6 divided by 11. So the Vm value what we get here is, so the value of Vm is 180 divided by 11. Okay, now we got the value of Vm. What is the value of Rm? Rm is just reciprocal of sum of all the reciprocals resistances. What is that? 1 by 1 by 1 plus 1 by 2 plus 1 by 3. Now when we solve this, we will get the value as 6 by 11. Okay, this thing's reciprocal. Okay, this is 11 by 6, and we will take the reciprocal of this thing, that will be what, 6 by 11. So this is the value of Rm. Now we have got the value of Vm and Rm. Now we can draw a circuit like this, and we can solve the problem. We have a simplified circuit which is like this one. Okay, and between the terminals A and B terminal, we had a 5 ohm resistance, and the current flowing through that 5 ohm resistance is what, I. Okay, so what we had to do, we had to calculate the value of I. Now we know the value of Vm. Vm's value is what, 180 by 11, and the value of Rm is what, 6 by 11. Okay, now this is a simple circuit. We know that I is equal to V by R from the Ohm's law, and the value of V is what, 180 by 11, and the value of resistance is what, this resistance plus this resistance, because these both resistance are connected in series. So it will be what, 6 by 11 plus 5. So it will be what, 180 by 11, 6 by 11 plus 55 by 11, and that will be 180 by 61. That will be approximately equal to 2.96. Okay, so the value of current I is approximately equal to 2.96 96. So this is how the MILLMAN'S theorem is used in the numerical problems.